Hi, everyone. What we're going to be working on today is something called the Law of Sines. And the Law of Sines is something that's used when working with non-right triangles when we want to calculate lengths of sides and angles. We must have either angle, side, angle, or angle, angle, side in order to use this particular formula. So I'm also going to explain that in a little bit different way. Visually, I'll show you what you need. So, law of sines is pretty simple. It's the sine of an angle. So, angle A is to the side opposite that angle. So, A equals the sine of angle B to B, which is equal to, you probably guessed it, the sine of angle C to C. And when we use this formula, we'll be using two fractions at a time. So, we'll be solving proportions essentially. So, let's take a look at our first example. And the example says that we have a triangle where we have angle, angle, and a side. And what you'll notice is this side is opposite this angle. That's really an easy check to figure out when you can use this. So let's go ahead and let's sketch a diagram of this triangle. Okay, I always go for my obtuse angle first. Okay, we know that angle A is 33 degrees. And we know if this is angle B, this would be side B opposite angle B, which is 37.9. And let's just label up the other sides. We know that we'll call this C, which means the side opposite that is side C. And then here's A, so here's side A. So what I always like to start with is the angle and the side that's opposite it. So the sine of 105 is to 37.9 as, and now the only other thing that we've been given is the 33-degree angle. So the sine of 33 is to, now remember that's angle A, is to A. And now we're going to go ahead and we're going to solve this proportion. So when we solve the proportion, we cross multiply. A times the sine of 105 equals 37.9 times the sine of 33. Okay, and then we have to divide by the sine of 105 on each side. Okay, and you're going to put that in your calculator. Now, a couple things. Make sure you're in degree mode. And if you're not able, if your calculator doesn't have the capacity to do the top bottom fraction, remember that you can put parentheses around the entire numerator, or you can do it in two steps. Do the numerator and then divide by 105. Either way, make sure that you get approximately 21.4. And I do think it's important to write that on our diagram because we're going to check something a little bit later. Okay, so let's move on. And now, if you look, we're missing angle C and side C. So angle C is the one we're going to go for right now because we remember from geometry, the triangle angle sum theorem says that the three angles of a triangle always add up to 180. So what we will do is simply subtract 105 and 33 from 180. A little simple math here, and we get that the measure of angle C is 42 degrees. And now we're going to use that the same way that we use the 33. I would say go back to the given information. So sine of 105 is to 37.9 as, and now we have that 42-degree angle, so the sine of 42 is to side C. And then, of course, you're going to cross and solve. You might want to just jump to this step. 37.9 times the sine of 42 divided by the sine of 105. Okay, if you need to write the other step out, the in-between step, by all means do it. Again, when you put this in your calculator, make sure that you get 26.3. We're going to put that on our diagram, 26.3. So I'd like to do a little check at the end. I'd like to make sure things kind of worked out. So if you notice, I have the largest angle, and opposite the largest angle is the longest side. Then we look, and I have the smallest angle, 33, opposite 21.4, which is the shortest side. And then we have the medium angle, which is 42, opposite 26.3, which is the medium side. So the relative sizes do seem to work. So it's just a little check for you. If something's not right with yours, then you know you made a mistake. Okay, so here's what I want you to do. We love our word problems. I want you to go ahead and read this problem, and go ahead and sketch a diagram. And let's see if your diagram and my diagram match. So go ahead and do that. Pause this video, please. Okay, so hopefully you got this for your diagram, and maybe you were even able to go a little bit farther and actually calculate this top angle here. See, with this information right here, we would not be able to use the law of sines because we technically don't have a side and the angle opposite. But we can do 180 minus 42 minus 37 to calculate that top angle, which comes out to be a 101-degree angle. And now we have a side and an angle opposite each other. So let's go and let's see how we do. Sine of 101 is to 9.3 as the sine of 42. You can call that whatever you want right now, x. Okay, that'll be one of our proportions. And we go ahead and solve. We get x equals 9.3 times the sine of 42. We're just cross multiplying. This is just a proportion divided by the sine of 101. Okay, make sure you put that in your calculator, and you should get about 2.25 miles. So 2.25. Again, put it on your diagram. Go ahead and do the second one. Pause the video. I think you have this by now. Pause the video, see if you can do it. Set up your proportion and write it all out. Okay, so I got 2.02 for the other hiker's distance. Okay, check the math, check everything. Again, you got to be in degree mode. So 101 is opposite 9.3. That's the longest to the biggest angle. The smallest angle is opposite the shortest side, and the medium angle is opposite the medium length side. So it kind of makes sense. It all works out. Got one more, and what I'm going to do is I'd like for you to stop the video. See if you can draw this diagram. This is an interesting one. And then once you're done with your diagram, start the video and see if we match, and then you should be able to solve it. Okay, so you might have had a little bit of trouble with this one. So remember, we have the balloon. It's at a certain height, and they looked down. So here's where they're looking down, okay, at a building. Angle of depression was 65.8. And then the balloon floated up another 500 feet. That's my balloon. It's terrible, but that's my balloon. And then they look down. Okay, so angle of depression here is 70.2 degrees to see that same building. We have to figure out how far is the balloonist from the building. Well, we've got some work to do before we can even get that. First thing I want to tell you is that this right here, from this purple line to this dotted line, is a 90-degree angle. And we need that because that angle is actually inside the triangle. So we can actually figure out that this angle right here is a 155.8 degree angle. So we'll hold off on that for a second. We'll just draw a little arrow, 155.8. Okay. And in this particular case, we're trying to find how far the balloonist, okay, here's the balloon, is from the building. So we're trying to calculate the length of this red line right here. So we don't really want to be outside of the triangle here. So what we'll do is we'll say 90 minus 70.2, and that will give us this inside angle here. So this inside angle, I'm running out of room, is 19.8 degrees. So we have one angle right here is 155.8. The other angle is 19.2. And why did we need that? Well, we have to calculate this angle down here because this is the only side length we have, and we need the angle opposite that. So you're going to do 180 minus 19.2, and then also subtract another 155.8. What you should get is that is a 4.4 degree angle. Okay, so a 4.4 degree angle in there. And now we're going to be able to calculate how far the balloonist is from the building. So we have, and again, let's look for a side and an angle that are opposite each other. So we have the sine of 4.4 is to 500 as the sine of 155.8 is to, we'll just call that x. Okay, and then you're going to cross and divide as always. So 500 times the sine of 155.8 divided by the sine of 4.4. And by the way, I do want to see that work right there. I know that this is something that many of you might be thinking, oh, I can just put it in my calculator. I don't need to write it. Wrong. You need to write it. I want to see that work. Okay. So what we find is the balloonist is 2,671.6 feet from that building. Okay. So hopefully you're having a good understanding of law of sines. Have a wonderful day, everybody.